This question is from lesson 18, section 8.3. It's about De Moivre's theorem. And the question is, if you have negative 1 plus I to the power of 9, how can you write this expression in rectangular form x plus ye and yi, and in exponential form of r e to the power of I theta? This is a question. Now, I clicked on get more help and then help me solve this tab so that you guys can understand what's going on with each problem. It first asks me, which theorem are you going to use to answer this question? And the answer is the Moivre's theorem. And then it asks you, what is the Moivre's theorem? And then the Moivre's theorem is, if you have a complex number z, which is equal to r times e to the power of I theta, and then whenever z is getting raised to a certain power of n, you must raise your r to the n power, and you have to multiply your angle by that n power. That's the theorem. Now it's going to keep asking me questions about this. Remember, the main idea for this question is we have negative 1 plus I to the power of 9. We want to raise negative 1 plus I to the power of 9. Now, to use this theorem, first convert the complex number to an exponential form to this. Since the given complex number is in rectangular form, first write the given complex number in polar form. So we have exponential form, we have polar form, and we have rectangular form. Rectangular form means x plus yi. Complex number in exponential form means r times e to the power of I theta. And in polar form means r times cosine theta plus I sine of theta. So we're going to convert this negative 1 plus I to the power of 9 to the exponential form. But before we convert it to the exponential form, first we're going to convert it to a polar form. So the x value, the first number is negative 1. And then the y value is the number before I. So we have just positive 1i. So that makes my negative 1 and positive 1, x and y value. Now, after I got these two right, next it's going to tell me how do you get to r. Remember, the r formula is square root of x squared plus y squared. So when I square these numbers, add them up and take their square root, the expected answer here is square root of 2. Check the answer, and it says we get the right r value. Now, we're going to find a cosine theta and sine theta. So cosine theta formula is given here, x over r. Since the x value is negative 1 and r value is square root of 2, this is, I can give them as the cosine value. But if we multiply the top and bottom by square root of 2, this cosine value actually changes to negative square root of 2 divided by positive 2. And then same thing for sine. Sine y value is positive 1, and we're going to divide it by root 2. So it's 1 over root 2. But I'm going to rationalize the denominator. So the top will be square root of 2, and then the bottom will be 2. This will be the sine value, and I will check my answer. Now, so I need to think about an angle who is between 0 to 2 pi, and the cosine value is a negative root 2 over 2. Sine value is a positive root 2 over 2. So cosine is negative, sine is positive. This is only possible in the quadrant 2. And the reference angle is pi over 4. So in quadrant 2, pi over 4 becomes 3 pi over 4. So the angle here I need is 3 pi over 4. Now, after we answer this, now this negative 1 plus I in polar form can be expressed as square root of 2 times cosine of 3 pi over 4 plus I sine of 3 pi over 4. Because the formula is r times cosine of theta plus I sine of theta. So we just changed our rectangular form of our complex number to the polar form. Now, we're going to write this complex number in our exponential form. So we want to keep working with this complex number, and we're going to change it to an exponential form, which is r times e to the power of I theta. So r value is square root of 2. So I will just need my square root of 2 here. And then I will exit from the radical sign, and I need my e. And I'm going to raise this to a I times theta. I times, and the angle here is 3 pi over 4. 3 pi over 4. This is how we express this polar form in exponential form like this. And then when I check my answer, it'll say that this is also correct. Now, finally, we are at the part of the question that we're raising our complex number to the power of 9. So I'm going to have to raise this complex number to the power of 9. So they set it up all for me. So this is what you have in polar form, and we're raising it to a 9th power. But because this wasn't easy to work with, so you just changed it to an exponential form, and you're raising it to the 9th power. And if we apply this theorem, all we have to do is take the square root of 2 to the 9th power. And then here, the angle will be multiplied by 9. And then the angle is 3 pi over 4. And then check my answer. And that's how we get the right answer here. Now, if we do the work associated here, which is square root of 2 to the power of 9, square root of 2 to the power of 9 is 2 to the 4th power times root 2. So it's going to be 16 root 2. And now I'm on the exponential part. So e to the power of I. I'm going to erase this I, and I'm going to put up the I for my method. So 9 times 3 pi over 4 is just 27 over 4. 27 pi over 4. So I need the 27 pi here and over 4 here. And I check my answer. This is how we get the answer to this question. Now, since the angle we got 27 over pi is greater than 2 pi, we have to change this to an angle corresponds to a 0 to 2 pi. So what I do is I divide 27 by 4. It goes 6 times. So 4 times 6 is 24. 3 is the remainder. So when you go around the unit circle 6 times, you will just come back to the same angle. But what is important for me is the remainder. So the remainder angle, or the coterminal angle with 27 pi over 4, is just 3 pi over 4. This is the coterminal angle with 27 pi over 4. Now I got the angle, and then therefore the exponential form for this question is 16 root 2 e to the power of I 3 pi over 4. And then that means this negative 1 plus I to the power of 9, which was in rectangular form, this is how we express it in exponential form. Now we're going to put this back into the rectangular form. So to put this back into the rectangular form, we're going to convert the complex number to polar form again. And then polar form means 16 radical 2 parentheses cosine of the angle, and in this case it is 3 pi over 4. 3 pi over 4 plus I sine of 3 pi over 4. And then we're going to close this. And then this is how we write this complex number in the polar form. And now, after polar form, we're going to evaluate cosine 3 pi over 4 and sine 3 pi over 4 to convert this to a rectangular coordinate system. So cosine of 3 pi over 4 is negative root 2 over 2. And here I need sine of 3 pi over 4, which is just root 2 over 2. And then I'm going to check my answer. Okay, now when we perform the multiplication here, root 2 times root 2 is just 2, and the top 2 cancels the bottom 2, and all I get is 16 times negative 1 here, which is just negative 16. Similarly, it's the same numbers that we are multiplying, but it's just positive, plus 16i. This is how I answered this question about section 8.3, and it's about the Moivre's theorem. This is how you solve this question.